Here we look at Grignard reagents. Grignard reagents, very useful, used in organic synthesis to increase the carbon chain length. And it does it by forming new carbon-carbon bonds. They're formed by the reaction of a halogenoalkane and magnesium. So R is obviously any sort of organic group, an alkyl group. X is any halogen. And that will form the following. This RMGX. Now, let's unpick this a little bit. What we've got then is this compound here, this Grignard compound, is called an organometallic, and that's due to this carbon-metal bond. There's many different types of organometallics, but here we've got a carbon-magnesium bond. And because carbon's very electropositive, it's got a very low electronegativity, it will have a delta plus, and the carbon bonded to it will have a delta minus. Now, we can simplify this and we can assume that this here has in fact just got a negative charge. So we get this species now called a carb anion. That's a carbon with a negative charge. And that can act as a nucleophile. Okay, lone pair donor. Now, this nucleophile here can behave in the same way as a hydride ion or a cyanide ion when they react with aldehydes and ketones. So let's have a look at the mechanism of this, or remind us of the mechanism of how Grignards would react with aldehydes and ketones. So I've got my R group. Again, this is sort of any sort of alkyl group, and that can react in the same way as, say, hydrogen or hydride ions or cyanide ions when they react with aldehydes and ketones. So we get this initial attack. So we're forming a new, this is my new carbon-carbon bond forming. We get an intermediate formed. Remember, an intermediate is a species formed in one step of reaction and used up in a later step. So that there is my new carbon-carbon bond. I've extended my carbon chain. Got this oxygen now, the negative charge, and it's now going to add a hydrogen ion. I cannot kick anything out of the molecule. There's nothing with a good leaving group. And that then produces an alcohol. The type of alcohol depends on whether you have an aldehyde or ketone to begin with. So that is the mechanism. As I said, the mechanism there is very similar, in fact it's identical, to the mechanism with hydride ions and cyanide ions with aldehydes and ketones. It's a nucleophilic addition reaction. So if we have, for example, an aldehyde, if you've got an R group and a H group on there, the product form then will be a secondary alcohol. If I swap one of those hydrogens for an R group, then hopefully you can see that the product now becomes a tertiary alcohol. So aldehydes and Grignards give secondary alcohols. Ketones and Grignards would give tertiary alcohols. These Grignard reactions can also react with carbon dioxide in the same mechanism to form carboxylic acids. Now let's have a look at an application of these Grignard reagents. Well, in a video that we looked at on Diels-Alder reactions, we looked at how this natural product thebaine, which is extracted from opium, that can be used to synthesize a drug used to treat heroin addiction called buprenorphine. And one of the first stage in thebaine going to buprenorphine is the Diels-Alder reaction, which I showed in my video on Diels-Alder. And this shows you how we get this bridge here. And there's the bridge. That bridge then would need to undergo reduction to get rid of the double bond. But what we've got then is now this compound here with this ketone group. And you hopefully should be able to see a ketone can react to produce this tertiary alcohol. So if this group here now, this compound here, reacted with the following Grignard, so now this that I've highlighted there in red, this now in effect is now my R minus. Okay, that's now my R minus. That will undergo a reaction exactly the same as this here. Okay. So in the example below, let's just have a look. One of the R groups is all this here is one R group, and the other R group is this CH3. That will react with this Grignard here, where that's now my R minus, and that there is the mechanism. That produces, remember, a tertiary alcohol, and the product form there is a tertiary alcohol. So that is Grignard reagents, very useful to increase carbon chain length. Mechanism, basically the same as a nucleophilic addition with hydride and cyanide ions with aldehydes and ketones. And there you can see an example of the use of Grignards in the synthesis of the drug buprenorphine used to treat heroin addiction.